Okay, so my name is Raffael. I'm from Federal University of Pernambuco in Brazil. And I'll be presenting my work about analysis of social presence in online discussion today. Just to give a small spoiler of our next presentation, not today, but I think it's Friday, we have another paper about cognitive presence. So it's a complementary paper. If you want to use this kind of inquiries model, you can go also to the other presentation. Okay, to give just a small contextualization of the work, in the few last years, the number of courses in online learning and blended learning settings had been raised a lot. And within these courses, the LMS platform has took a very important place. And these platforms have some different kind of resources that can provide interaction between students themselves and also between instructor and students. And my work focuses mainly on discussion forums, and we're going to analyze these topics and the messages in these online discussions. The online discussion is one of the resources that provide the most interactive option for students to talk to each other and also to ask questions to the instructor. So it has several benefits for online courses especially, but it also can be very messy for instructors to follow up all the messages and questions that are popping out in the discussion. So I've been working on online discussion for 3 years now, and we are trying to provide some methods for teachers to try to understand all of this mess that usually happens in active online discussion. My goal, my paper follows the education concept called community of inquiry. It says that to reach a good educational experience in online environment, the students have to have two different dimensions, like social presence and cognitive presence. And the cognitive presence try to measure if the students are reaching a higher level of cognition during the discussion. The teaching presence aims to understand the behavior of teachers during the discussion. And the social presence focus more on the interactions between these students and instructors during the discussion. And as I'm going to present a work about social presence, I also brought some additional information about it. Social presence is divided into three major categories: affective, interactive, and cohesive, and several indicators for each one of these categories. So I listed here in this table the categories and also the indicators. As we can see, for example, indicators of affective is expression of emotion and use of humor. And for interactive is basically the main category in general because it has indicators like continuing thread. So if you are just replying to someone's posts, and also asking questions that in general are the main goal of our online discussion, and so on. So in general, the interactive category has more messages related to it. And finally, the cohesive tries to analyze if the students are creating this sense of group that is very important to development of the online discussion. The literature shows several works that had proposed the analysis of this social presence, also the cognitive presence, so the analysis of community of inquiry in general, but they rely on manual coding. So for manual coding, I mean the coding of the message itself of the online discussion, or self-reports that are submitted to the students after the course. So in other words, these results can be analyzed only after the course. It is useful for the theory and to improve the teaching design, but on the other hand, it's not possible for the instructor to use and improve the course during the same course that is happening and that's being analyzed. So in the last few years, there were several classifiers proposed, especially for cognitive presence, that try to automatize this process of coding the messages in online discussion. And there are several papers that approach cognitive presence, not only for English, but also for Portuguese, for example. However, the literature will still lack classifiers for social presence. And then this is the main goal of this work, but we also asked another questions. I just summarized the main research questions of my paper. The first one is the development of the classifier itself. The second one is the analysis of which features has the best prediction power related to each of social presence categories. And finally, the third research question, we apply the automatically coded message to ENA analysis, epistemic network analysis. I will explain about this later on. And we compare this automatic classification with the manual coding to see if we can measure the similarities and the differences between the model that was generated with in both cases. So let's go to the method. The data and course design was, it was a course that was happening in Canada, and it is a master course about software engineering. You can see in this table in the left the main topics of the course. The course had, the data that we are analyzing have 6 runs of the course. So it's the same course, but over different semesters. The first 2 rounds of the courses were account for this control group, and the last 4 was for the treatment group. I'm not gonna present any details about this intervention because it's not the focus of my work, but I included the reference here. So if you want to know what's the difference between control and treatment, you can go to this reference. The point here is to show that the number of students in control and treatment is similar in a sense, but especially the posts. So the number of messages between control and treatment are pretty much the same. And for all this data, there were 2 expert coders to classify this, manually classify this each message in the indicators of social presence. So this is these are the numbers for the counts of messages within this. In total, we had a little bit more than 1,700 messages. So this is the count of message that was account for each one of the indicators. And this is the percentage of agreement. Again, I haven't did anything regarding coding here because this data was used before in the previous work of my research group. So you can check the code process in this reference. And if we combine the numbers for each indicator in categories and also divide in control and treatment group, we would have something like this. And we can see that the numbers are pretty much the same from control and treatment group. And the total is in this last part of the table. And as we can see also, these 3 highlighted indicators has the majority of the message. By the way, each message can have more than 1 indicator. So continuing thread, complementing, vocative had a lot of message coding these indicators. So basically, for example, 2 of them are related to interactive. And if we account the message from both of them, we will basically say that every message belongs to interactive. So we decided to remove the marks for these 3 indicators. And we ended up with this coded data For each category, we have negative for the message the number of messages that doesn't have the category, any indicator of the category, and positive if it has at least one of each category. Again, these numbers won't match the total number of messages that we have, because one message can have more than one indicator. And with these 6 runs of the course, we divided our data into training test, but we haven't divided the data just by the number of messages. We divided data in courses itself, so we left the last run of the course as test data, and then we divided the training data in 5 folders, one encompassing each one of the messages for these runs. We did this to avoid data contamination in the analysis, and even though we use this different type of separation between training and test, we can see that the percentage of positive and negative category is pretty much the same for every category. For the effective one, it's a little bit higher for negative in the test, but if you go to see the interactive and cohesive, you will see that the percentage are almost the same. So we think that this test data is well representative of the rest of the general data set. And then we use some text mining features to start the analysis of the data. Initially, we use 2 traditional text mining tools and resources to extract information other than the words itself. So we use LIWC that has several word counts representing different psychology processes, and also Coh-metrix that has several measures among other things like text coherence and text readability. But we also use the traditional bag of words approach with some pre-processing steps like grammatical correction, stop word removal, and stemming. We use smooth to oversampling the data because the data was very imbalanced. We also used random forest classifier as our main classifier because one of the goals of this paper is to analyze different features that predicts different classes of cognitive presence. We decided to go for a white box classifier. And we use this cross-validation technique, but using each course run as a fold. So we divided it in a 5-fold in the training phase using the courses run. We also optimize the main parameters of the random forest classifier. So basically we plot this graph to show when the numbers of, the first one is the number of attributes in each tree of the random forest, and it stabilizes around 1500. So we decided to go for 2000. And in this case, it's this number is stabilized around 600. So we decided to go for 800 trees in the random forest classifier. And then I will move to the results. First of all, the results of the classifier in the training set, just to highlight that the improvement with the tuning of the parameters. Initially, we have, by the way, I forgot to mention that initially we tried to develop a classifier to categorize the 3 classes at the same time, but as there were a lot of messages with more than one class, the classifier didn't reach a good result, so we decided to go for 3 different classifiers and with binary classes. So basically this classifier, we have one classifier for each category, and the classifier is the classifier categorizes the messages with or without this category. So for the training data, we have all of the tuning parameters increased all the categories output, So we can see here that we reached very good results in terms of both accuracy and kappa for affective and also interactive and cohesive. And then we applied the best model to the text set. And still we reached very good results for interactive and cohesive. And the results for the affective one is slightly worse, but even though we reached 0.34 of kappa, and this result was not that good because the affective class has less message, so it's more imbalanced. Okay, so the results for the classifier was this, and then we analyze the top 15 most important variables for each category. There are a lot of things that we could discuss about this table, but I will highlight a few of them because of the time. First of all, we are analyzing the affective category now, and I just put here the table for with the category and the indicators. And first of all, I would like to highlight these words of hope and happy. And we can see that these words are related to affective because it's somehow it's expression of emotions, positive emotions. And also we highlight this first pronouns in the first person of singular that is related especially to the self-disclosure indicator. And finally, we also have a couple of negative emotions indicators, so it's also related to emotions. In this case, the emotions are not only positive, but it can be also negative. For the interactive, I highlighted this question mark that is pretty much related to the indicator 7 that is asking questions. So it's the most relevant for interactive category. As we can see here, the importance is almost 4 times more than the second indicator. And I also highlighted the second person of plural features because they are related to the indicators like referring to explicit to other message or quoting message from quoting previous message. So in general, this kind of messages are citing the author of the message. And finally, I also highlighted this word that means agreement. So it's also related to interactive because of the indicator number 9. Finally, the cohesive table. We have several features related to salutations, both at the beginning and at the end of the messages. And we also have this LIWC social process measure. It is a measure that shows how the group is becoming cohesive over the time. And I also highlighted this first person of plural here. They expect specifically the pronoun we, that it also shows the sense of grouping. So it shows the cohesive category. We also use this classifier to reproduce the result of our previous work. And in this previous work, we basically used the epistemic network analysis to analyze the 2 different groups of students, the treatment and the control group. For I can provide more insights on how to use epistemic network analysis later, but for the moment, I will just say the features that we use in the previous work and that we are reproducing them. We use students as unit of analysis and conversation, and topic probability and social presence categories as codes. The main thing that I would like to show you in this analysis, this last analysis, is the graph generated using the automatic coding and the manual one. They are pretty much the same, as you can see in general. I highlighted a few things, so we can see in this bottom part of the the graph that there are a few blue nodes in the left side. By the way, blue nodes are for treatment group, students from treatment group, and red nodes are students from control group. We also can see that the means of each group are pretty much the same, and also with the same variance. And up here we can see that there is a few red students going to the right side and a few blue students in the left side. So the partner is the same in both graphs. And we also plotted the subtraction network to show the difference between the two groups with both automatic code and manual code. And as we can see again, the graph is pretty much the same. And if we pass a line between dividing the two groups, we can see that the line goes from cohesive to general comments in both cases. They are slightly different from each other, but they follow the same partner. And also the social presence categories are more or less in the same part of the graph together with this construction method topic. And the rest of the topics are pretty much in the bottom part of this graph. Okay, to summarize everything, the paper proposed 3 binary classifiers to identify the social presence categories. We also performed the analysis of the most important feature for each category. And then we demonstrated that we can use the automatic labeled data to generate the epistemic network graphs, and they are very similar to each other. We also had run some statistical tests that shows that the graphs are statistically similar. As feature works, we want to work on the reduction of the dimensionality of the feature vectors. As we are using a bag of word vector, it still take a lot of time to train the classifier, and also to evaluate with a larger sample sizes and even including different contexts like texts in Portuguese as well, or different texts from different courses. Okay, so this is it. Now I'm open for questions.